without any further delay, I would like to, get into the session. So let me just present the PPT. Give me a moment.
And Vinod, 1 minute. Participants,
Yeah.
this session will be the proper blend of theoretical aspect of Async IO and the hands-on. He will be sharing some of the programs with the Async IO capability and without Async IO capability. And Vinod, I think you're going to touch this the Python's capability of Async IO with Java capability, right? When it comes to concurrency. Am I right?
That I won't be doing it.
Okay, because yesterday I've seen some of the Java codes and okay, fine. I do not want to interfere much about your plans. Over to you. You can start present your screen.
All right, no problem. Yeah, as Srikanth explained, we'll be going through the theoretical part of it, and then I'll just go ahead and write a very simple program to explain you what difference the asynchronous way of Python makes and in terms of performance and other complexities. Okay, let me present the PPT. Hold on. All right. So hope you all able to see the presentation. So this is what we're gonna start with. So let's first talk. We're not going to talk about what is Python, but we are going to talk about why is Python. Why most of the industries choose Python for what advantages it has. And the next one is what is parallelism in computer programming. And then next we'll talk about what is single-threaded programming compared to parallelism, and also we'll see what is synchronous way of writing a program in Python, and also we'll see how we're going to write the asynchronous way of Python and what difference it makes between sync and async. And there's a reference document link I'm going to provide to you guys, wherein you can just go through that to get a in-depth idea about. And if you have any queries in between, yeah, of course, you are very welcome to interrupt and ask me question. I'm very much okay to help you all. How much ever I know. Okay, let's start. Okay, so as you all know, I hope most of you people know the basics of Python, because when I was studying my BTech, Python was not that so famous language, so we were totally into C, C++, and Java. But since you guys are most recent students, you must be knowing very well about Python. So Python is a high-level language. It is very easy to learn. It is like almost like you write a essay or a statement. You don't really need to worry much about machine-level way of programming. So all you need to learn is high-level language. It is very easy to learn. That's the reason industry picks up Python for most of the development. That is one thing. And next thing is platform independent. So you write a Python program in Windows, and you take the same program and run it on Mac OS and also Linux and other versions of Linux, anything, it'll just work. So it is totally platform independent. And when it comes to C, C++, and other languages, you yourself have to take care of managing the memory, and also you will always run into memory leak, all kind of issues. But when it comes to Python, it is all taken care by Python itself. You don't need to worry much about it. So that's one big advantage, I would say. And there is no explicit machine language compilation. So you know that there are other languages wherein you have to write a program in high level, and then you have to separately use a compiler to convert the high level language to the machine language, so that the machine understands and then runs the program and gives the output. But when it comes to Python, we can't say there is no compilation in Python. There is a compilation part, but it's just that you don't need to do it as a programmer. You just write a high-level language program, and then you just hit Python and xyz.py. What really happens whenever you install a Python on any kind of platform, we have something called PVM, which is Python virtual machine. So whenever you hit execution, It is given to that virtual machine, and the virtual machine takes care of compiling the code to machine language, and then it gets executed. So it is a very big advantage is that, you don't need really a compilation. You don't need to do it by yourself. It is taken care already. And another advantage is larger community. There's a big development community who are like, developing Python more and more. So if you are a Python developer, if you develop something and you get stuck somewhere, you just join as a member in Python community and ask any question. There'll be thousands of people to come and help you. So that is another advantage. And I have not got opportunity to work on artificial intelligence but machine learning, but a lot of my friends who are into that field, they're all using Python because it plays a major role there, since it has other lot of advantages. So this asynchronous IO module in Python is being introduced in Python 3.4, and then it is being developed continuously till Python 3.7. So it has a lot of advantages which we are going to see in future slides. Okay, so next is what is parallelism. So before we understand, since I'm trying to make you guys understand what this asynchronous way of Python programming going to make any difference, I want you all to have a very basic idea of what is parallelism in programming. So let's take this program as an example. So where we have like 3 functions, which is 3 tasks, and we are going to run all these tasks as a separate thread. So what happens really when you execute this program? So we have a CPU and we have CPUs with multiple cores. So here, for an example, we'll take the CPU which has like 3 cores, core 1, 2, 3, 4, and also we have a scheduler on top of that. So when we hit the execution of this program, we have a main thread, and since we have created 2 other threads for this particular program, each thread, it's actually a job of scheduler. Once you give the program to the scheduler schedules a thread 1 into a separate core and another thread into separate core. So what really happens when your function 1 gets executed on a core 1, in the same time your function 2 gets executed on the core 2. So it is parallelly gets executed. So I'm talking about the scenario. It is not concurrency. Just keep it in mind. I'm not talking about a scenario wherein a resource is being shared by 2 threads. I'm talking about a totally independent thread. Thread 1 doesn't have any dependency on thread 2, and thread 2 doesn't have any dependency on thread 1. So it is a very simple program wherein thread 1 and 2 both are running in different cores and parallel time. So that is parallelism. And what is single-threaded programming? So that's what happening in Python. So Python is actually a single-threaded programming wherein it is just 1 thread. When you write a program with 3 different functions, it is being given to your PVM, and then PVM takes it and runs it on any specific core. So function A, function B, function C, everything is tied to 1 single core. It cannot be run on parallel cores. So function A gets executed, and once that is done, function B gets executed, and once that is done, function C gets executed. So that's the single-threaded process. So that's the difference between the parallelism, like multi-thread process, and single-threaded. So now let's pitch into a basic Python which is synchronous. So any program in Python you write which is all synchronous. So let's talk about synchronous way of programming. So here we have given a very simple example of synchronous. Okay, so before we get into the coding and all, let me just give you a small real-time example between just to get an understanding between synchronous and asynchronous. So let's take an example, in a bank, wherein we have 3 different customer, and we have a cashier. So now we are talking about synchronous, wherein we have just 3 customer and a cashier. That's all. So customer 1 wants 2,000 rupees notes, customer 2 wants 100 rupees notes, and customer 3 wants 500 rupee notes, and we have a cashier. So all three customers stands in a line, and the customer who is in need of 2000 goes to the cashier, and cashier delivers the money, and then he moves out of the queue. The same way 100 goes next and 500 goes next. So that's the way of synchronous. And now let's think, what if the cashier doesn't have 2000 rupees notes, or maybe he's waiting for someone to come and give him 2000 rupees notes so that he can deliver it to the customer. So what happens in this scenario when it comes to synchronous? So the person who stands in the queue who was in need of 2000, he has to wait. He's going to hold the complete queue. The person who is in need of 100 rupees and 500 rupees, so though the cashier has 100 and 500, just because this 2000 rupees note is not available, he is still going to hold the queue. So only the waiting time is over, only when the 2000 is available, he will be delivering the 2000 to the customer, and then queue will proceed. So that is asynchronous. Now, that is synchronous, I'm sorry. Now we take then another example, which is for asynchronous. Let's take the same scenario wherein we have a cashier and 3 customers, and we have a person called queue manager. So that guy is very important when it comes to asynchronous. So the queue manager, what he does, he takes control over these customers. He will decide which customer has to go first, which customer has to go next. So what happens in this scenario? The customer who is in need of 2000 rupees note, he goes to the cashier, and the cashier says, I don't have 2000 rupees notes, to the queue manager. So what the queue manager does, okay, so there is no 2000 rupees note at the right time. So he will take out the customer who is in need of 2000 and he will put him on wait. He is not going to hold the job of cashier. So he is going to let the person who is in need of 100 rupees and 500 rupees to the cashier. So they will be completing their job and then go out of the queue. Once the 2000 rupees notes available, the customer who is on the waiting list, he will be put it back to the queue so that he will get his money. And then, so in this way, what is ensured? Your CPU, the cashier is actually your CPU core. So your core is always being utilized. It is not waiting on something. So your core is always utilized. When something is waiting on input, output, the other tasks gets executed, and this job is perfectly taken care by your queue manager. So the queue manager is what? Your async IO guy. So that's the main advantage of this. You're not going to waste any of your resources. So this is the thing which is expected in the industry, that, you know, effective way of programming with respect to space complexity and also time complexity, performance, and everything. So when it comes to Python, when you talk about async IO, people will really be impressed because you know an effective way of writing a Python program. So let me show you. I hope you all understood the, you know, very simple asynchronous program here. So we have a main, and which has 3 functions calling with different numbers, and that is going to call a function which is going to add a number and deliver it. So this is going to work in a synchronous way. Add number of 1000 and 2000 executed first and result is printed, and 1020 executed next and result printed, and 100 200 is last. So adding a number and result is being printed, and adding a number, result is being printed. So that's how it does work. Let me show you another slide where don't look at the program right now. So just I'm going to explain you the syntax, how the syntax changes when you want to convert your normal way of programming to async way of programming. So here you can see I'm importing a async IO module. So this async IO module is what I was talking about, which was being developed from the version Python 3.4 to 3.7, and it is still being developed with a lot of other advantages. So you have to import that module. That is one you know, important thing. And then whatever the functions you have written earlier as dev function name, you have to add a async key before it as a prefix in all the functions. And any function which is being called inside your function, that should have a await. So await key says that, you know, if there is when you call that particular function, if that function is going to wait on something, you just suspend there and then give an opportunity to the next function. That's what that await means. So as you can see, in all the functions, I have added async as a prefix, and whatever the function being called inside that async function, I have added await as a prefix. So let's come to the beginning of this program. So as you can see, from async IO, I'm calling a function called get event loop. So this get event loop is what going to deliver you a queue manager. So it is like async IO is the person who has a queue managers. So you're going to grab one of the queue manager to manage your functions. So this get event loop going to give you a queue manager, and then the manager has a different way of executing your functions, the queue. So as you can see here, I have used run until complete. So when you say run until complete and main, this is going to run all your function until all your function gets completed. There is one more thing which is called a run forever. For example, if you're writing a programming for a server and that server is expected to run always, so you can use run forever. So likewise, we have other set of tasks which you can, see by, looking into the reference, which I'm going to give it to you. So that's how it works. This is all you have to understand when it comes to syntax point of view. Just you have to import a async IO module and, add the prefixes which I told, and get a loop, which is your queue manager, and then add your main function into that queue. So it is going to run one by one. So now let's get into the hands-on. Okay, so I hope you all can see my screen. All right, so here I have a very basic, program in synchronous way. So you can see I have, written this program based on the example which I given to you, in the bank. So we have a main function here, and we are going to call this guy collect money, which is there. So he's going to do simple. I'm just printing cashier preparing to deliver whatever the notes the customer requesting for, and in between we can do some task. Maybe he can go to the wallet, and take the money, and then he delivers it to the customer. So that's all. It's very simple. So let's just execute this function and see how this works. It is asynchronous. It is synchronous way. It is so simple program. So when you execute it, you can see the order. Cashier is preparing to deliver 2000 rupees notes, and then customer successfully collected it. And cashier preparing for 100, and he delivers it, and then 500 is being prepared and 500 delivered. So as you can see, it is in the same order how we executed 2000, 100, 500. And also it is in the same order, like it is launching a function, and then it is completing, and then moving on to the next function, 2000, 100, 500. 2000, 100, and then 500. So that's how the order is. So this is pure synchronous way. Okay, so let me tell you how to convert the same program into asynchronous. So as I told you, first we are going to import a module called async IO, and as I told you, you need to have the Python version which is above 3.4 to import this module. Import async IO, and then we are going to add this prefix async. So now I'm going to lend a queue manager. Okay, so let me call the manager async IO dot get underscore event underscore loop, and I'm going to add this main function into that manager. So the manager will take care of it. Run underscore something complete main function. So as I told you, any function going to get called inside async function should have a prefix of await. So the next thing what we're gonna do is we're gonna put all three guys into a single queue, which is await async io dot wait. Just add it in a single queue so that it all gets executed at the same time. Okay, so this is the way to convert a normal Python program into a async await way. So now let's try to execute this. All right. Get event loop. Hold on a second. Let me just.
Hello, Vinoth. Hello, Vinoth.
Yeah.
You need to add close bracket in the end of await. You need to add close bracket.
Sorry, did I make a syntax? Thanks a lot. Okay, so is it Prabhakar?
I'm assistant professor in Sasuri College.
Hey, hi. If you don't mind, can you go on mute? I'm sorry, I'm hearing a lot of noise. Thank you so much. So now you can see that, let me just show you the last execution. So it was in order 2000, 100, and 500. Now actually you can see the order is being changed. It is like 100 is being executed first and 200 and 500. But you can see the order what we have given is 2000 and 100 and 500. So which means your queue manager has totally taken the control over this queue. Though you have you're executing in this order, this queue manager has a randomness in him that he uses some logic and he decides who needs to be sent first. And every time that changes, all right, anyways, it's not changing this time. So so your order is being changed now. We have successfully converted the synchronous way of Python program into async in the syntax wise. So now we have to see how we have to see how it really makes a difference when it comes to performance. That is what we have to see. So what I'm going to do is I'm going to introduce a delay here. For example, this async IO module has a sleep. So I'll show you. We have a normal sleep in the time module and we have a sleep in async IO module as well. So what I'm going to do right now is I'm going to use a sleep of 10 milliseconds between each and every function execution. So if you can notice, I have imported a module time and I'm going to make use of the sleep function from the time module. So let's see what happens. So you can see it is not making any difference in the order. It is executing in the same order. So it goes to the cashier and then waits for 10 milliseconds and then it delivers the cache. So that's how it works. So let me show you what happens when I use a sleep which is from async IO module. Okay, so let's execute this function. So now you all can see, instead of waiting for the 100 rupees note to come, it is actually launching all the customers to the cashier first. So the customer went to cashier and asked for 2000. Since we have introduced a delay of 10 milliseconds, the customer has to get suspended out of the queue. So he's been suspended. And then the next person who is in need 500 is being sent to cashier, and there also we have a timer. So he's been suspended again. So the time we suspended the 500, the 2000 rupees becomes available, so he gets delivered. So as you can see, the order has been completely changed. It is not waiting. So earlier it was waiting and completing and then allows the next function for execution. But in this, you can see that, all the functions is being launched at the same time. And also you can see the results also being delivered at the same, mostly at the same time. Okay. So probably, if you just see the function without having any performance data, you won't understand. So let me add some code to see the difference really with respect to performance. So what we can do is, let's take a time before execution, time, and then we'll take the time post execution. And let's say execution time is T2 minus T1 and print me the time for execution in milliseconds. Okay, we'll have to multiply with 1000 to get it in milliseconds. So what we can do is, first I'll show you what happens when I use normal time. As I told you, Async IO has a lot of functions with built-in functions in it. That's the function we have to use when we totally go convert into a async way of programming. We're not supposed to use the normal time sleep. So I'll tell you how this performance is getting. So now you can see for each function we have introduced a delay of 10 milliseconds. So it goes and waits for 10 milliseconds and then gets the next function gets executed. So end of the execution, you can see that all three functions got executed with the delay of 10 milliseconds. So all got accumulated, and you can see the time of 31 milliseconds for this complete execution of this function. So let's convert it into a pure asynchronous way by using asynchronous sleep. So now I'm going to execute the same function. Now you can see all those functions are launched at the same time, and more or less all the function execution is just 10 seconds. So that's the performance we get when we switch the asynchronous program to async way. Maybe since we have taken a very simple programming as an example, we are seeing the performance in milliseconds. Probably if you take bigger programs wherein you are involving the servers, wherein you are waiting on a server to respond back, or you have some socket communication and all, where we will see really a better performance in this. So I think we are almost in the end of the session, and this is one of the reference which I always go through when you really do a deep dive into this async IO. Probably I can share it with Srikanth, this link separately. You can go through it. And it is very simple. You can start with very simple program, and then you can go and read through the lot of modules which are already available in async IO. Like sleep is one of the thing. Like sleep, we have a lot of other functions which are already being written to use it in an async way, which you can make use of it in your program and make it work really effective. So that's all from my side. Thank you guys, and if you have any questions, yeah, you can shoot.
Vinod, I'm here. And again, it is 12:36 now. You are very prompt while delivering the contents, it seems. Like, you know, I was handling another meeting, and just now I came back. And participants, like, you know, if you want to ask anything, you can very well ask. Participants, whatever the doubts you have. Mr. Jagan, I request Mr. Vinod to stay back.
No, I'm not dropping.
Okay. Mr. Jagan? Participants, stay patient as the feedback form is getting ready. So that I'll drop you the link there. Meanwhile, you can ask whatever the doubt you have. Vinod, how about the hands-on? Like, you know, participants, if you have any requests, like, you know, hands-on, it can be done. If it can be done one more time, it could be more familiar for us. Mr. Vinod is ready to give the hands-on once again.
Yeah. It's being recorded, right, Srikanth?
Yeah.
Okay.
From the chat window, Mr. Jagan, he works for Cognizant Technology Solutions. Vinod, he said,
hi, Jagan.
Session is really good.
That's great.
Yet again, I have a question to you, Vinod.
Yeah.
The concurrency ability. Can you compare the concurrency ability of Python with concurrency ability of Java? If you are not quite unsure about Java, give me the concurrency ability of Python. Then I can virtually compare it with the concurrency ability of Java.
Okay, so when it comes to concurrency, concurrency is something, you know, not so successful in Python, I would say. We have something called GIL, if you heard about. You know, it's Global Interpreter Lock. I guess that's the you know, the abbreviation for that. So what happens really? I have not really worked on that. But I can you know, do a little bit of study about that and give you offline.
Okay. One more question from my side. Can you give the difference between synchronous communication and asynchronous communication?
Okay, communication. You mean when you talk to a server?
Yeah, client-server communication.
Okay, so for example, let me just show you that function. So here we have used a module called sleep, right, from Async.io.
Yeah.
So you might have used a function called connect, or, you know, there are a lot of other functions to talk to your database, say Postgres, or, you know, other database. We have a predefined function in Python, which are all in a synchronous way, like how we imported sleep from time, which is sync. We have other set of functions called connect, and, you know, if you want to connect to the Postgres DB, or if you want to connect to a host by giving a username and password and everything, those functions are implemented in Async.io as well. So let's just you know, take an example wherein say you're trying to connect Async.io dot connect. You give a username, and you give a password, and you give a port number. So what really happens when you do this? It goes and tries to connect to the server, If in case if the server is busy or down, it is not going to hold your next function. It is going to, take that function and puts on the wait list, and your CPU core has been released for your next function. And once the server becomes available, your queue manager will get an interrupt from the core that you were waiting on a server and the server is responding now. You can put that guy in back to the queue. So the same function, which is the same function which is actually trying to make a connection with the server, will be put back into the queue, and he will get executed. So that's how it works. So likewise, we like connect and sleep. We have plenty of functions which you can make use of according to your development and the requirement.
Good. And any views from participant side?
Hello.
Yes, Jagan.
Hi, Vinoth.
Hi, Jagan.
One small question.
Mm-hmm.
I think that I'm waiting for that call actually. So we are writing an asynchronous program, but see, just now you have written that connect, right?
Mm-hmm.
After connecting, you are getting some user ID or something. Okay.
Mm-hmm.
Only after getting that, I have to perform a few steps. So how you will manage that here?
Sorry. Can you tell me again? Yeah.
See, you have your connect,
Mm-hmm.
and after that you have your print, right?
Right. Yeah.
So your print is not going to wait for your connect to complete.
No.
Here.
The tasks which are all falling under the same function, which is going to wait. You
Okay.
get my point? So you're saying the print which is coming after connect will get executed. That's
Correct.
your assumption, right? No.
Correct.
It is totally a function based. So if it is going to wait on a particular line, the
Okay.
lines which is after in the same function is not going to get executed. It is totally giving a way to the next function.
Okay.
Yeah, that's how it works.
Okay. Thanks.
Okay, I think you have explained the synchronization problem, it seems. It's a very classic problem. And again, another question from participant side. Mr. Pratish Krishna asked, what will happen in case of deadlock?
Okay, so the concurrency, I mean, the deadlock thing I have not explained here. So as I told you, the deadlock is something is not very successful approach in Python. I read about it, and even in our industry programming, we don't, choose this way of programming if we get to know if there is any race in our development well before in the time of designing itself. However, in Python we have a way of handling deadlock which is GIL, as I already told this to Srikanth, which is a global interpreter lock. So by using that, you'll be able to log the resource which is being shared by multiple functions, and then once the function makes a proper, completes the update properly with the commonly shared resource, and then the logs get released, like how we handle it in C, the same way. But somehow it is not so successful, because the reason is your Python PVM, it is always tied to one single core. So the racing conditions and all, it's not going to work in an effective way when it comes to Python, is what my theoretical explanation. But I have to really read a lot about it.
I don't think so, Vinod. Jagan, what do you say? Because what Vinod is saying, the race condition, performance-wise, the race conditions will not, Python PVM may not handle the races. But again, it is globally.
It will.
Yeah.
It will handle. That's why we have that GIL I was talking about. It can handle very well, but the thing is, it is not going to be as efficient as how it is going to get handled in other languages, is what I'm trying to say.
And
it is something possible, but it's not effective.
Okay, fine. And one question to all Python enthusiasts in this group, and again, including the presenter, including Jagan, and again everyone. Like, you know, what you see when you compare Python with Java, I don't know. But I always compare Python versus Java as superstar versus universal hero. Rajinikanth versus Kamal Haasan. Lot of industry projects are well connected with Java-based technologies, and a lot of technologies which got evolved after 2010. Some of the engineers across the globe, they are when it comes to machine learning, deep learning, they are particularly they are focusing on Python to build their libraries. And some of the recent works done with the help of Python, to be very frank, they are not irreversible. The library written in Python, like, you know, whether you like it or not, you need to set up the Python environment and you need to grab it, whatever the API call that you use. What may be the reason for that, Mr. Vinod? As you are a Python enthusiast, you can explain. Mr. Vinod?
Okay, I didn't get your last point actually, which you explained.
Okay, why the recent technologies, when it comes to like particularly AI, the machine learning and deep learning, most of the libraries, they are purposefully they are making it as irreversible algorithms. Like, you know, the whatever they written in Python, like, you know, you cannot take it to other natives.
Okay.
Why the recent developers loves Python so much?
As I told you, I've given some few points. See, now you're talking something which actually, you know,
irrelevant to the current
Java
topic.
and Python works together. Yeah, that no, maybe it is relevant just because, you know, I don't have enough knowledge on Java. You know, I can't confidently come and answer this question. That's a problem.
Jagan, can you answer? Why the yeah?
See, previously, you see the right count of the Python engineers. See the count of the people who knows Python. இதுக்கு முன்னாடி பாத்தீங்கன்னா வந்து ரொம்ப கம்மியா தான் இருந்தாங்க. There were only very few people who knows Python, but இப்போ நீ academicsலயே ஆட் பண்ணிட்டீங்க Python. So the engineer who is coming out of college right after 4 years, right, he's now knowing Python.
Yeah.
So they have enough resources to go ahead and do things in Python, and that's one reason. But உங்களோட question answer பண்றதுக்கு வந்து I'm not sure. I have to go ahead in Python. அப்புறம் தான் எனக்கு தெரியும்.
Okay.
இது வரைக்கும் நான் Pythonல ஒர்க் பண்ணல.
புரியுது. ஏதோ ரொம்ப வாண்டடா பண்றது மாதிரி தெரியுது ஆக்சுவலா. They cannot shake the fame of Java. அது for sure. ஏன்னா இன்னைக்கும்
அது பண்ண முடியாது. ஏன்னா lot of legacy systems are running in Java still, and நிறைய பேஸ் லெகசி சிஸ்டம்ஸ் அவங்க இன்னும் ஜாவால தான் வச்சிருக்காங்க. ஸோ அதெல்லாம் மைக்ரேட் பண்ணணும்னு நினைச்சாலே அது வந்து இட்ஸ் a very huge process.
தலையில மண்ண வாரி போட்டுக்கிற மாதிரி.
கண்டிப்பா. பட் ஸ்டில் சில ப்ராஜெக்ட்ஸ்லாம் கேள்விப்பட்டேன், ஜாவால இருந்து பைத்தான் மைக்ரேட் பண்ற மாதிரி ப்ராஜெக்ட்ஸும் காக்னிசன்ட்ல போயிட்டு இருக்குன்னு கேள்விப்பட்டேன்.
ஓகே.
ஸ்டில் தே டூயிங்.
ஓகே, ஆக்சுவலா நான் இந்த சேஞ்ச் நான் பார்க்க ஆரம்பிச்சது 2014ல தான் ஜெகன். ஒரு பெரிய அக்வசிஷன். அவன் சன் மைக்ரோ சிஸ்டம் ஆரக்கிள் வாங்கணும்னையும் கூகுள் தனியா ஒரு R&D டீம் போட்டு காட்லின் ஒரு லாங்குவேஜ் டெவலப் பண்ண ஆரம்பிச்சிட்டாங்க. 2012ல
கரெக்ட். சோ அதுக்கப்புறம் தான் இவங்க என்ன பண்ணாங்க, ஜாவா சைட்ல இருந்தும் வந்து அதை விடக்கூடாதுன்னு சொல்லிட்டு தான் ஜாவா 8 அப்கிரேட்ஸ்லாம் கொண்டு வந்தாங்க. ஸோ இவங்களும் ஃபங்க்ஷனல் ப்ரோக்ராமிங்குள்ள ஜாவா டைவ் பண்றதுக்கு மெயின் ரீசனாவே அதுதான் ஆச்சு. ஸோ அதர் ப்ரோக்ராமிங்ஸ் ஃபுல்லாமே நீங்க காம்படிட்டரா பார்க்குற எல்லா ப்ரோக்ராமிங் லாங்குவேஜஸ்மே மோஸ்ட்லி ஃபங்க்ஷனலா இருந்துச்சு. ஸோ அண்ட் ஜாவா வாஸ் நாட் ஃபங்க்ஷனல். ஸோ தே ஸ்டார்ட் இன்ட்ரடியூசிங் ஃபங்க்ஷனல் கான்செப்ட்ஸ் இன்டு ஜாவா அண்ட் தே இன்ட்ரடியூஸ் லாம்டா ஸ்ட்ரீம்ஸ் அப்படின்னு சொல்லிட்டு ஜாவா 13 வரைக்கும் பாத்தீங்கன்னா மோஸ்ட்லி ஃபங்க்ஷனல் தான் அடுத்து அப்டேட்ஸ்ல எடுத்துட்டு வந்துட்டு இருக்காங்க. ஸோ அவங்களும் மார்க்கெட்ல நிக்கணும் ட்ரை பண்றாங்க. பட் அது எவ்வளோ எஃபெக்டிவா இருக்கும்ன்றது தெரியல.
இந்த மாதிரி அக்வசிஷன்லாம் சம்டைம்ஸ் ரொம்ப ரூத்லெஸ்ஸா இருக்கு. அது ஆனா நம்ம கையில ஒண்ணும் இல்ல, அவங்ககிட்ட காசு இருக்கு வாங்குறாங்க. இப்ப ரீசெண்டா IBM கூட ரெட் ஹாட் வாங்கினாங்க. அது ரூமரா இல்ல என்னன்னு தெரியல. IBM ரெட் ஹாட் வாங்கினது if anyone knows, அது ஆனா ரொம்பவே என்ன ஹர்ட் பண்ணுச்சு. ரெட் ஹாட் என்ன மாதிரி ஒரு இனிஷியேட்டிவ், எப்படி அவங்க உள்ள வந்தாங்க, ஓப்பன் சோர்ஸ்னு ஒன்று இருந்ததுன்னா இந்நேரம் இப்பவும் மைக்ரோசாஃப்ட் தான் நம்பர் 1, அவர் தான் நம்பர் 1 பில்லியனியர். இப்படி ஒரு ஓப்பன் சோர்ஸ்ங்கிற கல்ச்சர் இல்லை அப்படின்னா இன்னும் அவங்க என்னென்னலாம் பண்ணியிருக்கலாம் அவங்க. அதனால ஐ டோன்ட் ரெக்கமெண்ட் த கல்ச்சர். இந்த மாதிரி அக்வசிஷன்லாம் கொஞ்சம் சென்சிபிளாக பணம் மட்டுமே இல்லாமல் கொஞ்சம் இவ்வளோ பேர்த்தோட கான்ட்ரிபியூஷன் அண்ட் அவங்களோட எஃபர்ட்ஸை பார்த்து பண்ணால், இதுக்கு ஒரு முதல்ல ஒரு கன்சோர்டியம் வைக்கணும். பணம் இருந்தால் மட்டும் அக்வயர் பண்ண முடியாது அப்படின்னு ஒரு கன்சோர்டியம் இருந்தால் நல்லதுன்னு தோணுது. இட்ஸ் மை பர்சனல் தாட். எனிதிங் எல்ஸ் ஃப்ரம் த பார்ட்டிசிபென்ட் சைட்? வேறு ஏதாவது கொஸ்டின் இருக்கா? Vinoth, meanwhile, you can check the chat window. I request you all to give your valuable feedback. URL is right there in your chat window. I'll get the material, and in the comment section, don't forget to give your email ID so that I can share the material what I'm going to receive from Mr. Vinothkumar Shanmugasundaram. Thank you all. Thank you once again, Mr. Jagan and Mr. Vinothkumar. Thank you for your session.
Thank you, Srikanth. Thank you, everyone. All the best.